Hello everyone! Today, we're journeying into the golden fields of sunflowers to see how these radiant blooms are transformed into one of the world's most popular cooking oils, sunflower oil. From the moment a tiny seedling first peeks out of the soil to the massive industrial presses that extract the rich oil, we'll uncover the entire process by which millions of sunflowers are grown, harvested, and processed. By the end, you'll appreciate just how much science, engineering, and labor go into producing that bottle of sunflower oil in your kitchen cabinet. Sunflower oil is cherished worldwide for its light taste, versatility, and relatively high smoke point, making it ideal for frying, baking, and salad dressings. Large producers like Ukraine, Russia, Argentina, and parts of Europe and North America supply a vast global market. Over the last few decades, industrial-scale farming and advanced oil extraction methods have evolved, boosting yield and lowering costs. As a result, sunflower oil has become a staple in many households, competing with other oils like soybean, canola, and palm in both culinary and commercial applications. In grocery stores, you'll often see different varieties of sunflower oil, some labeled as cold-pressed and others as refined. Each type caters to particular cooking needs, such as high-heat frying or light sautéing. Sunflowers thrive in temperate to warm climates where they can soak up abundant sunlight, key to generating healthy seeds with high oil content. Farmers prepare fields by tilling and ensuring proper soil fertility. Seeds are then planted at calculated depths and distances to maximize sunlight exposure and prevent overcrowding. Hybrid sunflower varieties, bred for disease resistance and optimized oil yield, dominate large-scale operations. Irrigation methods vary by region. In areas prone to drought, drip, or pivot systems are often used to maintain consistent moisture. Elsewhere, moderate rainfall can suffice with minimal intervention. Good weed management and targeted pest control also prove vital, guaranteeing strong plant stands without excessive competition or damage. In North America's Great Plains, many farmers use precision GPS-guided tractors to plant sunflower seeds in perfectly spaced rows. This ensures each plant receives optimal sunlight and nutrients, ultimately increasing the total oil yield at harvest. Once germinated, sunflower seedlings emerge, quickly shooting upwards. Over weeks and months, they develop sturdy stalks that can reach heights of 1.5 to 2 meters, 5 to 6 feet or more. Distinctive bright yellow flower heads follow the path of the sun throughout the day, an adaptation known as heliotropism. That's basically nature's version of always follow your dreams. Except in this case, the dream is a really bright ball of fire in the sky. As the plants mature, each flower head, technically an inflorescence, is made up of hundreds or thousands of tiny florets. Pollinators like bees help fertilize these florets, forming seeds. Farmers monitor fields for signs of pests or diseases like downy mildew or sunflower beetles, intervening with biological or chemical controls as needed. Optimal plant density and nutrient availability further encourage large, oil-rich seeds. Around mid-summer, a field of sunflowers can look like a sea of gold. This is the prime time for photography lovers. Meanwhile, agronomists check random plants in the field, slicing open seeds to assess oil content and overall ripeness. Determining the best harvest moment is crucial. Growers watch for seed moisture levels and the browning of back petals on the flower heads. Typically, farmers look for seeds at around 9 to 12% moisture before harvest to prevent spoilage during storage. If seeds are too wet, they can mold or require additional drying. Costly, and time-consuming. Modern farms rely on combines adapted for sunflower heads. Large headers gently cut the stalks and funnel heads into the machine, where seeds are threshed out. Minimizing seed loss is a key objective. Each plant can produce hundreds of seeds, and even small inefficiencies can lead to major yield drops across extensive fields. In some regions, farmers use color-coded harvest maps generated by drones. These maps show which areas of the field have the driest seeds, allowing the combine harvesters to focus on those spots first. After harvesting, trucks or wagons deliver seeds to collection points or directly to the oil processing facility. Here, the seeds pass through an initial cleaning stage, removing stalk fragments, leaves, and debris with vibrating screens and air blowers. Some plants also use magnetic or optical sorters to catch any foreign materials. If seed moisture is above the factory's threshold, often around 8 to 10%, drying is mandatory. Industrial dryers blow heated air through seed layers, gently reducing moisture. Overdrying can crack seeds and reduce oil output, so skilled technicians monitor temperatures and airflow to ensure an ideal balance. A farmer might bring a truckload of sunflower seeds to a co-op facility where staff first weigh the truck. They then perform a quick moisture test. If it's above 10%, the truck heads to the drying bays to bring moisture down to the required level. Sunflower seeds can be stored for months in large silos or warehouses, assuming they remain cool and dry. This flexible storage allows factories to run oil production year-round, even if harvest is seasonal. Aeration systems may circulate air to prevent hot spots or condensation, which could trigger mold or rancidity. Inventory management software tracks each silo's capacity, seed origin, and quality data. For traceability, farmers and cooperatives often label batches with harvest date, variety, and region. Should a quality issue arise, factories can isolate the suspect silo or batch quickly. In a large-scale operation, the silos might be equipped with temperature sensors that alert managers via smartphone if any region of the stored seeds begins to heat up, indicating potential spoilage. This proactive monitoring saves massive losses. When seeds are called up for processing, they undergo additional cleaning and dehulling steps. Dehulling, removing the tough outer husk, can significantly raise oil yield and reduce impurities. Some facilities skip full dehulling, depending on the end use or desired oil characteristics. Seeds then enter a conditioning stage, steam or hot air warming them slightly to loosen oil in the kernel. This step softens the seed's internal structure, boosting extraction efficiency. Temperature controls ensure the seeds don't overheat, which could degrade oil quality. Operators might maintain precise temperature ranges, such as 80 to 90 degrees Celsius, 176 to 194 degrees Fahrenheit, for specific durations. If done too quickly or at too high a temperature, seed quality can suffer, affecting both flavor and nutrition in the final oil. Expeller pressing. Expeller presses apply immense pressure, physically squeezing oil from the seeds. This process is simpler, more traditional, and generally yields a cold-pressed or expeller-pressed oil that retains more natural nutrients and flavor. However, mechanical pressing leaves some oil in the meal, residual 5 to 15%, so it's less efficient than solvent methods. Artisanal farms sometimes rely exclusively on mechanical presses, producing fragrant, cold-pressed sunflower oil. These oils often fetch premium prices in local markets. Solvent extraction. For maximum yield, factories often employ hexane or similar solvents, which dissolve the remaining oil from the pressed seed cake. The solvent oil mixture is then separated, and the solvent is distilled off for reuse. While more complex, solvent extraction can extract up to 99% of the oil, leaving a high-protein meal used in livestock feed. Some large-scale plants run a dual process. Seeds first pass through an expeller press, then the leftover meal is treated with solvent to capture the remaining oil. In modern solvent extraction plants, automated sensors continuously check hexane levels in the air. This ensures worker safety and compliance with environmental regulations. If solvent extraction is used, the seed meal, now saturated with solvent, undergoes dissolventizing in heated vessels. Steam or heat vaporizes the hexane, which is recaptured and cycled back into the system. The resulting meal, protein-rich and low-fat, is either pelleted or ground for animal feed. Throughout the plant, closed-loop systems minimize solvent losses and reduce emissions. Strict safety protocols handle the flammable nature of hexane, ensuring well-ventilated areas and explosion-proof equipment. In some facilities, advanced odor control systems help manage the strong smell that can come from hexane-based processes. Neighbors appreciate these measures, especially if the plant is near residential areas. The raw oil leaving presses or solvent extractors is called crude sunflower oil. It typically contains impurities like phospholipids, free fatty acids, pigments, and waxes. To produce a clear, stable cooking oil, factories refine it through several stages. Degumming. Mix in oil with water or acid to remove gums, phospholipids. Neutralization. Adding alkali solutions, e.g., sodium hydroxide to neutralize free fatty acids. Washing and drying. Water rinses remove soaps, then vacuum drying eliminates moisture. Bleaching. Clay or activated carbon adsorb pigments and residual impurities, leaving a lighter color. Deodorization, steam distillation at high temperatures strips volatile odor compounds, resulting in a neutral-smelling stable oil. For specialized or gourmet oils, minimal refining, like partial bleaching or skipping deodorization, may be applied to preserve distinct sunflower flavor and nutrients. High-end food brands sometimes specifically label their sunflower oil as lightly refined to indicate a more robust flavor and potentially higher nutrient retention. Chefs might prefer these oils for dressings or low-heat cooking. Sunflower oil's natural waxes can form cloudiness or crystals in cooler climates. Winterization or dewaxing addresses this. Factories chill the refined oil to near 0 degrees Celsius, 32 degrees Fahrenheit. The waxy components solidify and are filtered out, ensuring a clear product even under refrigeration. After winterization, the oil is typically 100% transparent and stable across a broad temperature range. This clarity is essential for consumer acceptance in many markets, particularly for those expecting crystal clear cooking oils. If you've ever stored sunflower oil in a cooler environment and noticed a white cloudy layer, it's those waxes. In fully winterized oil, that cloudiness won't appear, so home cooks can rely on consistent clarity every time they pour. Multiple checks ensure oil meets stringent standards. Labs regularly measure free fatty acids, FFA, indicate oil breakdown. Peroxide value detects rancidity levels. Color and clarity, evaluated using specialized colorimetric systems. Moisture content. High moisture can spoil oil. taste and aroma, sensory panels sometimes test final products for off flavors or metallic notes. Regulations also cap contaminants like pesticides or heavy metals, ensuring consumer safety. If a batch fails, factories may reprocess or discard it. Product consistency is paramount for brand reputations in the highly competitive edible oil market. A factory might pull multiple samples from each production run. Technicians then run these samples through devices such as spectrophotometers and gas chromatographs to verify compliance with strict standards before approving oil for bottling. Refined oil moves to large holding tanks, monitored for temperature and inert gas blanketing to prevent oxidation. When ready for market, the oil is piped to automated bottling lines. Plastic, glass, or metal containers vary by brand and region. Machines rinse and dry each bottle, fill it, seal with caps, and apply labels. Packaging designs highlight health benefits like vitamin E content or claims of being trans fat free. Batch codes enable full traceability, so if any defect arises, the factory can quickly recall or isolate the issue. Bottles are then packed into cases or shrink-wrapped for pallet transport. Some plants use laser coding technology to mark each bottle with a date and batch number. Retailers can scan this code to track exactly which pallet and ultimately which field the oil originally came from. Sunflower oil is a pantry essential in many countries, prized for neutral flavor and stability. Factories partner with distributors or supermarket chains to stock shelves. Internationally, shipping containers carry bottled or bulk oil worldwide. Some retailers prefer large flexi tanks or 20-liter jerry cans for catering and hospitality industries. Seasonal fluctuations, like varied harvest times in Europe versus Argentina, help ensure a continuous global supply. Price dynamics shift with factors such as weather, geopolitical events, e.g., disruptions in major producing countries, and competing oil crops. A restaurant chain in Asia might purchase large drums of sunflower oil from Argentina in the off-season, then switch to Ukrainian oil when Argentina's crop is between harvests. This global interplay keeps sunflower oil consistently on the menu. Once the oil is extracted, seed husks and other remnants serve additional purposes. The protein-rich meal is a key livestock feed ingredient, boosting dairy and meat industries. Sometimes leftover biomass can be burned for energy or used in biogas plants, reducing waste. In integrated plants, pressed husks can become fuel pellets or be composted to enrich farmland. Such resource utilization underpins a zero-waste philosophy, where every part of the sunflower contributes to economic or environmental gains. Factories invest in continuous improvement, minimizing energy, water usage, and waste generation. In some eco-conscious regions, farmers collect leftover sunflower hulls to create biodegradable plant pots. These pots can be transplanted directly into the soil, breaking down naturally while nourishing the next crop. Sunflower oil's favorable fatty acid profile, rich in unsaturated fats, appeals to consumers seeking healthier cooking options. Some factories produce high oleic sunflower oil, boasting elevated monounsaturated fats akin to olive oil, well suited for high-temperature cooking. Others highlight organic, non-GMO seeds or cold-pressed artisan lines, catering to niche markets. As functional foods gain popularity, R&D explores fortifying sunflower oil with vitamins or antioxidants. The industry also experiments with sustainable packaging, like biodegradable bottles or easy-pour spouts. These innovations reflect evolving consumer demands for health, convenience, and environmental stewardship. A specialty brand might advertise its cold-pressed, high-oleic sunflower oil as having a buttery taste perfect for roasting vegetables. Health-conscious shoppers often compare these labels to other oils when deciding which to buy. Sunflower oil factories comply with strict sanitary protocols, HACCP, hazard analysis, critical control points, ISO standards, or local equivalents. Regulations in each region set maximum residue levels for pesticides, requiring thorough raw material checks. Labeling laws mandate nutrition facts, allergen statements if relevant, and origin labeling in many countries. Trade agreements and country-specific certifications like halal, kosher, or USDA organic open certain markets. Factories adeptly navigate these requirements, ensuring a consistent supply to retail and institutional buyers worldwide. A plant exporting to the Middle East might obtain halal certification, while the same facility could also process kosher certified runs for distribution in select U.S. grocery stores. Each run is meticulously documented to meet religious and cultural standards. The sunflower sector grapples with challenges: climate volatility, soil degradation, and water scarcity among them. Sustainable farming practices, crop rotations, precision fertilization, and integrated pest management help preserve yield while reducing ecological impact. Collaboration between governments, seed developers, and farmers fosters drought-tolerant, disease-resistant varieties. Meanwhile, advanced refining technologies and renewable energy adoption lower the factory's carbon footprint. In the future, synergy between agronomy, technology, and consumer consciousness will shape the sunflower oil industry, pushing for greener production and continuous innovation. Some modern refineries run partially on solar or wind energy, aligning with the sunflower's very nature, harvesting the sun's power not just for growth, but also for processing its seeds into oil. This closes the loop on sustainability goals. Sunflower oil's mild flavor makes it a favorite across varied cuisines, especially in Eastern Europe, parts of Asia, and Latin America. Ukrainian borscht, Argentine empanadas, or Indian puri all rely on sunflower oil for crisp, light results. Some cultures also prize cold-pressed sunflower oil for salads or finishing drizzles, preserving subtle nutty aromas. Festivals in sunflower-growing regions celebrate the harvest, reflecting the flower's cultural resonance, symbolizing positivity, warmth, and energy. Large-scale factories underpin these traditions, ensuring the market is well-stocked all year round. In rural communities of Eastern Europe, families often host summer events among blooming sunflower fields. Traditional dishes are prepared with fresh, locally pressed sunflower oil, and visitors experience the flower's importance in local heritage. From the time a sunflower seed is planted to the day a jug of oil graces a kitchen pantry, the journey is extensive and carefully orchestrated. Harvest timing, seed selection, extraction methods, and refining stages all converge to create a light, nutritious oil that's indispensable in countless recipes. If this exploration sparked your interest, consider subscribing for more behind-the-scenes looks at how everyday items are produced. Drop a comment on your favorite use for sunflower oil: stir fries, baking, or homemade salad dressing. Next time you drizzle or fry with sunflower oil, you'll know the elaborate journey each golden drop took, bridging fields of sunlit flowers and advanced industrial processes.